Welcome to EDU World Space.
So in this video, we're going to talk about question 92 from chapter 20, which asks us, what is a disproportionation reaction? Use the following reduction potentials to predict whether HCl2 will disproportionate. So a disproportionation reaction is one where one species is both oxidized and reduced. So you have a reactant that is oxidized into one product and reduced into a different product. So we want to know whether or not HCl2 will disproportionate. And we're given two half reactions, and the way they're written here, they're both reduction half reactions because we're gaining electrons. But for a redox reaction, we want to write one of these half reaction as an oxidation half reaction that can be coupled with a reduction half reaction. So which one do we write as an oxidation half reaction? Which one do we write in the opposite direction? So remember, when we write these in the opposite direction, we flip the sign on the reduction potential. And we want the overall cell potential to be a positive number, because that means that the way we've written the reaction, it will occur spontaneously. So when we're picking which one we're going to flip directions, which one we're going to write as oxidation, we're going to pick the one with the lower reduction potential. So we're going to take this first half reaction with a reduction potential of 1.21 volts, and we're going to write it in the opposite direction. So let's go ahead and do that. So that gives us HClO2 plus H2O yields HClO3 minus plus 3 protons plus 2 electrons. And then our other half reaction, we haven't changed at all. It's still written in the forward direction. It's HClO2 plus 2H plus 2 electrons yields HClO plus H2O. So we want to add these together. So let's figure out what cancels. So first, what cancels is our 2 electrons. Then we have a water molecule on both sides of our reaction. And then we have 2 protons in our reactants and 3 protons in our products. So our 2 protons cancel out and we have just 1 proton in our products. So the overall reaction that occurs spontaneously, because remember, we were careful to add these together so that our resulting cell potential will be positive, the overall reaction is 2HClO2 yields HClO3 plus H plus HClO. So this seems like it could be a disproportionation reaction. We could have HClO2 being reduced or oxidized to either HClO3 or HClO. But in order to determine that, we need to first define the oxidation states. So first, let's do this for our first half reaction. So we have HClO2. We know that the oxidation state for hydrogen is +1 when it's bonded to other atoms, and the oxidation state for oxygen is -2. So we have +1 and 2 over -2, so +1 and -4, and we want it to be overall electrically neutral. So the oxidation state on chlorine in this case is +3. Then in water, we just have +1 and -2 for hydrogen and oxygen. And then in our products, HClO3, again, our hydrogen takes a +1 oxidation state, and our oxygen takes a -2 oxidation state. So now we have +1 plus -6 from our 3 oxygens, and I need to add something to that to add to equal -1. So the oxidation state that satisfies that is +4. So the oxidation state is changing from +3 to +4. That's a loss of electrons. That's oxidation. So this is our oxidation half reaction, and chlorine is changing oxidation states from +3 to +4. Let's do the same thing for our other half reaction. So again, in HClO2, we have an oxidation state of +3. We don't need to go through that again. But let's go through HClO. So again, our proton takes an oxidation state of +1, and our oxygen takes a oxidation state of -2. In order for this to be electrically neutral, our chlorine is going to take an oxidation state of +1. So our oxidation state on chlorine from reactants to products in this half reaction is going from +3 to +1. That's a reduction. That's a gain of electrons, is reduction. So in this case, chlorine was reduced. So when we add our two half reactions together and get the overall half reaction, we have the same species, which is HClO2, being both reduced and oxidized. The chlorine is both reduced, going from HClO2 to HClO, and oxidized, going from HClO2 to HClO3. So yes, HClO2 will disproportionate.